solutions. So it's 4, so I can start officially. My name is Alfredo Pastor from HV Network. Thank you everybody for being here. We have here today Sebastian Irfan, I said, from SICK. We are going to talk about several solutions that SICK is proposing for localization and navigation, not only devices, because maybe many people only thinks about safety scanners or LiDAR for localization or these things. No, there is software, is only software. We are going to talk about a new integration into the SICK family from Axerion. Okay, so this floor localization system, very, very innovative. So today we have a lot of things to say. I don't speak anymore. Just Sebastian, please introduce yourself. Irfan, introduce yourself, and then we go with the presentation. Okay.
Sounds good. Okay, thank you, Alfredo. Hello, everyone. So my name is Sebastian Heinrich. I am product manager within SICK for mobile robot solutions, and I'm in the mobile robot market since over 5 years now, and I'm focusing on mobile robot solution products to localize and navigate mobile robots. Yeah, and I'm very happy to have the ability to speak here today together with Irfan and Alfredo. Yeah, welcome.
Great. Hey, so I'll go next. Welcome everyone, and thanks for being here. So my name is Irfan. I'm also one of the strategic product managers for Triton, and I've been with SICK since the beginning of this year. But I've been with the Triton family for now about 2.5 years, and you'll also know why there's a small difference. But yeah, quite excited to talk to you about our solutions.
Okay. Wonderful. Just to say one thing, because I was in SICK some months ago, and these guys are working in a team of brains. I mean, I saw a lot of people working for developing new things, putting sensors, putting software, thinking, well, how to mix these things. So it's a great team that they are working for developing all these things. And you know, when SICK is probably the most important company in terms of devices, okay, or equipment for localization and navigation in the industry, when they move and they do something, they do the things right well and with the right people. So this is why I'm saying this. It's an honor to me today to be here to speak with you about all these things. Okay, so I just put the presentation. If you agree with me,
yes, please.
Okay. Yeah. Wonderful, and then go ahead. Okay, I will listen to you. When I have questions, I will ask you. Okay, Sebastian, Irfan. And if I see some question in the chat that is interesting at that moment, so please, I already asked you. Sorry, because I will interrupt you. Okay, so don't get offended. I think it's going to be very interesting. We are going to see videos. We are going to see the presentation, technical stuff, application. So that's it's going to be very, very interesting. Please, Sebastian, the show is yours.
Okay, thank you, Alfredo. Then let's start. Yeah, today's topic is redefining precision. So SICK's approach to mobile robot localization, and we want to show you what we think how you should localize your mobile robots. Let's look at the menu. What's in for you today? So I will start with the first part. We will talk about natural contour localization. This is today I think the most commonly used technology to localize mobile robots, and we talk about localization of mobile robots with our products LiDARloc and PicoScan 150loc. And after that part, we will talk about the very unique and new technology. This is floor texture localization. Some might be already aware of it. For some, it might be new, and Irfan will take over the second part and tell you about our solution, Triton FloorLoc. And after that, if we have some time left, we can dive deeper into questions and discussion. Okay, then let's start. First thing I want to talk about is, so what is localization and navigation? So when we at SICK talk about localization and navigation, what do we mean? And with localization, we mean, so where am I? So where is the mobile robot? Or if you compare it to Google Maps, so the blue dot in the app. So the localization is the process of determining where you are. And on the other side, navigation, this is the question is, how do I get to my target location? So this is the process of moving from point A to point B. And I think sometimes it's mixed up. So if some people talk about navigation but mean localization and the other way around. So this is how we understand it. And for us, reliable and accurate localization is the basis for successful navigation. So only if you know exactly where the robot is, you are able to control it on the path you want to go and to reach your goal. Today I want to take the chance to present you the portfolio, what we have within SICK, to localize and also navigate mobile robots. So let's start on the left-hand side. We have LiDARloc. This is our product for 2D LiDAR localization based on natural contours. So it's a contour localization based on the contours of the environment, and it comes with an accuracy of typically 10 millimeters. Then we offer CodeLoc. This is a localization solution based on data metrics codes on the floor. So you apply codes on the floor, you have a code reader on the vehicle, and you use this to localize the vehicle. Then next is the virtual line navigation. This is a lightweight navigation solution. It emulates the output of a line following sensor. And this is a software extension to our localization. So if you use one of our localizations and use the virtual line navigation, you are able to easily follow virtual lines, and all you have to do is to write a line following controller and follow a virtual line, and you're able to seamlessly switch between virtual and physical lines.
Mm-hmm. Sebastian, you are saying here, okay, the LiDARloc is the LiDAR, I guess, for what is the SLAM navigation, okay?
Yeah.
What is an accuracy of 1 centimeter, so 10 millimeters, then the CodeLoc for the QR code, I guess, no? You can mix this in the same project. I mean, I have my mobile robot that is running in a corridor with the LiDAR, with the SLAM, so hassle-free, so easy to install, what is all the benefits of natural navigation, let's say. But then I have to have a precise positioning of a container or with a robot interface or whatever it is. I can switch from LiDARloc to CodeLoc in the same vehicle with the same software, or it's not possible?
Yes, this is absolutely possible. So we are a sensor company still mainly, and you can easily connect code reading sensor to our software, and then it seamlessly switch. So you don't need to do anything. The algorithm automatically uses the information he gets. So if he reads the code, he will process the code information. If he receives some LiDAR data, he will process the LiDAR information, and same with wheel odometry. So you can seamlessly integrate codes into the application. And as you mentioned, this is ideal for precise docking. So for example, before you enter a charging station or a point of interest, you can place a code on the floor if the application allows this, to place codes on the floor, and then you can achieve increased accuracy on the code of up to ±1 millimeter, and then you can use this increased accuracy for precise docking. Yeah.
Okay.
This is absolutely possible.
No, it happens because for example, of course, that you have a very precise docking, and you need to switch from one type of navigation to the other, I would say.
Yeah, exactly. Yeah. So we also have many customers using this, so to have a precise docking possibility. Yeah.
I have, regarding these tolerances that I'm seeing here, we have Roberto from Spain that is asking if this accuracy that we are writing here is let me check, is absolute error, or is a square let me check, what is the a square mean root mean square error?
So this is so if I drive to the position and then drive to the position again and again and again, I will achieve this accuracy. And this is the result at 1 sigma, what we specify in the specs. But in reality, so I think the 1 millimeter on the code, so this is if you're really on the code and a 10 millimeter. For the 2D LiDAR contour-based localization, we can even go below. But so it's a contour localization, so it heavily depends on the environment, on the contours. So 10 millimeter is what we specify, but if you test it in a contour localization-friendly environment, we can go below, so we can achieve accuracies of 2 millimeters. Yeah.
Okay. And what is the orientation error for the LiDARloc and CodeLoc?
The orientation error, I think it's 0.25 degree.
Okay.
Yeah.
Okay. Okay. Well, I mean, it's just another question from Roberto in Spain. Okay, let's go ahead. Okay, because there are already, I see, quite a lot of questions, so we are not going to rise to the Q&A section, my friends.
Yeah, but questions are good, are very welcome. So
I mean,
I try to
sometimes
answer
this
them.
is, of course, I take these questions in case of there is some specific, precise data. We will have all these questions and we will answer people also by email. So I don't ask you to have everything in mind today. You know, it's a question that people is asking in this month. So let's continue. Let's continue.
Okay. Yeah. So all these solutions are. So we have the PicoScan 150-log. This is a 2D LiDAR with embedded software, with embedded localization software, and also the virtual line navigation software is embedded. So we have one compact device where we put in all the software we have. So this is the PicoScan 150-log. I will talk about that product later. And then the new member of the family, the very unique and new technology, it's a Triton floor lock. This is a system where we have localization based on texture of the floor, and Irfan will tell you more about that in the second section. Yeah, so far to the portfolio overview, and now let's dive deeper into the contour localization and the PicoScan 150-log. So this is where I want to focus at today. And with LiDARloc, we have a natural contour localization, which means that we use the contours, the natural contours of the environment, and they are detected by a 2D LiDAR sensor and used as natural landmarks for localization. So we basically do a reference map of the environment, and then we use the current current sensor data, match it to the reference map, and estimate the position. And this is a heavily used technology in the mobile robots industry, and it's interesting for all manufacturers of all kind of mobile robots. The advantages are, or the benefits are, it delivers a robust localization, and we within LiDARloc, we have a powerful algorithm with seamless sensor data fusion. So this is, I think, this is where we really are good at SIG. So we are sensor specialists. So we know sensors well, and we are good in fusing and post-processing sensor data. So we fuse all the sensor data. We use LiDAR data, we use wheel odometry. Optionally, you can use reflector information, and you can also optionally connect the code reader to the system. Okay. So this delivers a robust localization for many applications. Then, as already mentioned, we have a high accuracy of ±10 millimeters, which enables precise docking and can even be increased if you add codes. So you can achieve 1 millimeter on the codes. Okay. And I think the real value in contour-based localization is that there's no infrastructure necessary, and LiDARs have a really huge range. So, for example, I don't know, 100 meter or even more, 200 meters. So, and if you have a 100-meter range, you immediately cover an area of 30,000 square meters. So you can really easily and fast commission huge facilities. And another advantage is that if you change so within this reference map, you can drive everywhere. So if you change your navigation layout, you don't need to remap or do anything like that. And another specialty for LiDARloc is that we support multiple LiDARs. So most vendors only support one LiDAR or maybe two LiDARs, but we can support up to 4 LiDARs. Some people might think, okay, why do I need to be able to connect 4 LiDARs? But they are
you mean at the same time, so simultaneously?
Yeah, exactly. So this is interesting if you have really huge vehicles with
of course,
with interesting shapes,
yeah,
and then you need additional safety lidars to cover the full field of view of 360 degrees, and we have the possibility with LiDARloc to connect all of these lidars to the localization system and use all the data, so you don't have to throw away necessary data.
Okay.
Okay, so and what are typical applications, or how do you combine the LiDAR localization with our sensors? So on the left-hand side, we have the safety LiDAR. So I think this is the most common section, since on most mobile robots, at least in the Western Hemisphere, personal safety is required on the mobile robots. You have the safety lidars on the mobile robots anyway. And with LiDARloc, contour localization, so you can use the data of the safety lidars not only to protect the people and stop the vehicle, but also to localize the vehicle. So you can solve two applications, localization and safety, with one sensor device. And I think this is the most common use case. And the LiDARs are typically mounted in that use case at a height of 150 millimeter scan level due to the safety regulations. And in the middle section, we have the picoscan. So this is a new device. This is a really compact but powerful 2D LiDAR, but it's non-safe. But it still has a collision avoidance within the device. So it can be used for localization and non-safe collision avoidance. And it comes with a long range of up to 120 meters. So the combination of LiDARloc and picoscan, this is an ideal solution for non-safe applications, which are maybe more common in the Eastern Hemisphere, but also as additional must-mount localization sensor. When we talk about forklifts, we typically have an additional localization sensor on top of the vehicle, and the picoscan is really a perfect device to solve this application. So why do you put an additional sensor on top? The reason is, so if you operate forklifts, you typically move pallets and boxes, and they block the field of view of the lidars, of the safety lidars. So if you have a must-mounted device, it just looks over the obstacles, and this is beneficial for the localization. And then on the right-hand side, we have the multiscan. So this is the a 3D device. So we have a 16-layer LiDAR, and what we did is we integrated the horizontal layer of this device into our localization software. So we can do a 2D LiDAR localization on the horizontal layer. And there's an on-device 3D object detection app. So you can do 3D object detection to detect ground-free obstacles. And this gives you a 2.5D mobile robot solution. So this might also be interesting, and it's really new in our portfolio.
Excuse me, what do you mean 2.5? Excuse me, Sebastian.
2.5. So this is how I call it.
Okay.
So we have
so it's a Sebastian terminology.
Yeah, exactly.
Okay,
this is a Sebastian terminology. So we have a 2D localization, 3D object detection equals a 2.5D mobile robot solution. So this is my own definition.
Okay. Now, one question, because you are saying that, of course, you can use several types of LiDAR, okay, with your LiDARloc, that's fine. But if I use the LiDARloc in combination with other LiDARs, for example, with the picoscan, do I need a SICK IPC, or I use another type of IPC to run the software? What do I need?
So we are totally open here. So if you want to use LiDARloc, you can deploy it either you can buy an IPC from SICK, or you can deploy it on your own IPC or any third-party IPC, so Linux or Windows, whatever you like, and you can connect the LiDARs. So you can even run it on a Raspberry Pi.
So in this, but can I also use this localization, I mean, in combination with my own ROS stack, or is not possible?
Yes, this is possible. So on GitHub, we offer a ROS driver for our solution. So for example, if you have your own ROS stack for navigation, this is totally fine for us. You don't have to buy the whole ecosystem from us. You can choose only the localization. So since we are really good in localization, and you can choose, okay, I want to use the LiDARloc, the SIG localization, but the navigation, so this is my own IP. I want to do it on my own, or I want to use my own ROS stack. So this is totally possible.
Okay, good.
Yeah, and altogether, so we have over 5,000 vehicles in operation. So, and not only, so in real industrial applications.
Excuse me, Sebastian, is 5,000 with the LiDARloc?
Yes, 5,000 with LiDARloc. So 5,000 vehicles operating worldwide, not only in Europe, also in the United States, in Asia, with LiDARloc in real industrial applications and in many, many different applications. So we have mouse vehicles, we have forklifts, we have clean rooms, we have semi-outdoor. So everything is possible.
So, but because I openly tell you, Sebastian, not the first time. I learned about the LiDAR was when I was visiting SIG some months ago. But it seems that it's in the market since a long time. I mean, it's like you are step by step launching it now, or because I mean, 5,000 vehicles is not a prototype anymore.
No, it's not a prototype anymore. So this is a full-blown product, and we are extending further and further, as you see with the acquisition of Xerion. So with the PicoScan 150 lock, I will talk about later. So we are also attacking the must-mount localization solutions. So we are in the market since.
Congratulations, because this is an impressive number.
Yeah.
Okay.
So we started in 2019 with LiDARloc, and okay, then let's talk about the PicoScan. So because we really think that the PicoScan is an ideal choice for localization. So we have a really compact device, but it's big in performance. So we have a huge working range, and this is also a really cost-efficient solution for our customers. So, and why do we think that this device is very interesting for control localization, especially for forklifts? So one thing is the working range, because if you mount it on top of the vehicle, you look over the obstacles and you look at walls and pillars, and they might be far away. So working range is quite crucial. And the second thing is the accuracy. So with the PicoScan, so the higher the accuracy, the more accurate the localization will be. And the last thing is the availability and the reliability of the device. So what brings you the best solution if it's broken because it's not sustainable enough for the rough industrial environment. And so these are the three key enablers, what we think, why this is a good solution for localization. So working range is best in class on natural targets. We reach up to 120-meter range. Then accuracy, we have a statistical error of smaller 2 millimeter. And what is important that we really test every device in our manufacturing. So you only get good quality devices. And third thing, the availability. So we really test also shock and vibration tests. We do shock and vibration tests. We have a robust design designed for this harsh environment. And we also have this multi-echo technology to have a good data availability. And this results in an ideal device for localization. And on the picture, you see measurements of the localization accuracy, so of the total overall system, not only the LiDAR, but also with the localization that we can achieve 2 millimeters. So we specify 10 millimeters, but if you have good environment, you can reach 2 millimeters. Yeah. Okay, and since we have now the best-in-class 2D LiDAR device, we have an industry-proven contour localization software. And then was the question, okay, what do we do? And we did we put the software in the device. So with the PicoScan 150Loc, it's called. This is a high-performance 2D LiDAR with on-device natural contour localization, and this is quite unique on the market. So we took the device and we put the LiDARloc software in it. We also have the code support, so you can connect the code reader. We have the virtual line navigation. So if you have a line following vehicle, line following controller, you can use this output to easily follow a virtual line. And we even have a 2D object detection app on board. It's non-safe, but you draw a field, and if it is violated, you can use it, for example, to stop the vehicle. So all of this in one compact device. And we believe that this is especially interesting for localization of mobile forklifts and automated forklifts and stackers.
Sebastian, we have Philip is asking if there is some kind of IMU in the sensor in the PicoScan 150.
Yes, there is an IMU on board, and there's also an IMU output, so you can use this IMU data for your own applications. The IMU is currently not yet, so we don't use the IMU yet for the localization, but this is definitely an additional leverage what we have for the future to improve the localization even more.
Mm-hmm. And what about the odometry, no? The wheel odometry. Do you recommend using it or not?
Definitely, yeah. So wheel odometry is always highly recommended when it comes to mobile robots. Of course, you can also localize without wheel odometry, but there are certain situations where LiDAR has some challenges. So if you have plain walls, long corridor issue, and you don't see the end and the beginning of the corridor, so this is more or less unsolvable task for the LiDAR only. And if you integrate wheel odometry, you can easily solve such an application. So we always recommend for robustification to integrate the wheel odometry. So we have an interface, and you simply feed in the odometry, and that's it. Yeah.
Mm-hmm. Then we have another question about the PicoScan, because they have a month Patel is asking how does what rate does PicoScan at what rate does PicoScan provide localization outputs?
It's about 20-25 hertz.
Okay, thank you.
Okay, so this device gives you a cost-effective solution, so you don't need an additional localization controller. So it's easy to integrate. You just plug and play. You don't need to deploy the software. You don't need to do some licensing or something like that. And since it's ultra compact, you can integrate it in almost any vehicle. But to show you how easy it is, I brought a video. So let's start with a video. I think this is the video. No, this is not the video. This one. Okay, so within this video, you see how easy it is to commission a mobile robot with the PicoScan 150Loc or LiDARloc. So we have a desktop tool for the creation of the reference map. You simply connect the PicoScan to the desktop tool. So it's mounted on a mast on a tripod. I'm driving through our mobile robot technology center, and you see some live mapping. So you immediately see if you cover all areas you want to operate in later, and then you simply click on start. And if you're done, you click on stop. Then the algorithm automatically generates the reference map, and all you have to do is to upload it now on the device. So the localization is on the device. You need to initialize once at the beginning. Then as soon as you're initialized, you're able to localize, and now you're ready to go. So it's a small environment, of course, but it was commissioned within 1 minute, and you're able to operate your robot now. And all things what are missing now are drawing the paths, of course, but from localization side, within 1 minute, we commissioned this small environment.
Do you have to clean the map? So is it possible?
Yes, this is possible. So we recommend to clean the map, so to remove all dynamic objects of the map and keep the static objects in the map. Yeah, this is possible in the tool, so you can do it manually. But for this small demo test, it was not necessary. Yeah.
Okay.
Okay, let's go back to the presentation. Oh. Are I'm back now? Okay. But to show you that this is not only demoing, so we really solve huge facilities and huge applications. So this is a facility where what we commissioned recently, and this is about 270,000 square meter. So we can do, of course, small environments, but we can also do huge environments. And of course, to commission such an environment, we need more time. But I just wanted to make clear that we do not only, it doesn't only work in the lab, it also works in real industrial environments. And another question what often comes up is, okay, what happens? So there are a lot of dynamics, a lot of dynamic contours. How does LiDARloc perform in such an environment? And I brought another video to demonstrate that. Of course, we recommend to use wheel odometry, which will robustify the solution. Then we do not only have the reference map, we also have LiDAR odometry. So we do a scan matching scan by scan. And this gives us an additional pose estimation or incremental pose estimation. And you can add reflectors optionally to robustify the solution. But as you now might see, we also have a really robust algorithm. So in this test, we removed a complete area in the map to test covered contours. So, and we were able to localize within this area purely on LiDAR odometry. So there's no wheel odometry included now. This is only pure LiDAR odometry. And as soon as we re-enter a known area, we are back and localizing perfectly well. So we managed to drive over 60 meters without losing the position. Okay, then let's jump back to the presentation. And now one last video from my side, and then I will hand over to Irfan. So the last video I brought is
a mobile robot. That is a mobile robot.
No, this is not a mobile robot. This is the company car. And I just wanted to bring our system to the limit, and I just wanted to know what is possible. And I mounted the PicoScan 150 lock on top of a company car. Then I used our tooling to map the city of Waldkirch, where SICK is located. So this is where our headquarters is located. And we localized while driving through the city of Waldkirch, purely LiDAR based. So of course, we don't have access to the wheel odometry. And yeah, I think it's quite impressive. So we mounted it on top of the car and then just went for a ride. And here you see the city center of Waldkirch. So of course here we have good contours, close buildings, but as soon as we reach the location, now we are outside, and here you see the big advantage of the PicoScan with the long range. So, and even at 50 kilometers per hour, we were able to perfectly localize with the BigOScan 150 lock.
50 kilometers per hour without. Okay, that's what. There's a scoop here, Sebastian. You are also doing Google Maps now. That's fine.
Yeah. Okay.
No, impressive. Yeah, no, because I mean we are working at 2 meters per second. I mean we are far below 50 meters per 50 kilometers per hour. But I mean having a good accuracy in terms of localization at that speed is already a performance that in logistics or production, I mean, it's not required, but I mean, it's impressive.
Yeah, thank you. Yeah, it was a nice test, and it was just fun to bring the system to the limit. Yeah,
that's good. Okay, well, wonderful. There are. We live. If you agree, Sebastian, go Irfan now with to present the new solution. Okay, and then because there are a lot of questions, and then we try to answer at the end some other questions about the PicoScan, about the LiDARloc, about other things. So we mix at the end some questions, and we try to answer as much as possible. Okay.
Great. So if you guys can hear me, then I'm going to start off with the newest localization technology from SICK, and we call this the Triton. So even though I call it the newest, actually Triton has a rich history that I just want to touch upon quickly. So Triton was developed by a Dutch startup called Axerion, just founded in around 2015. And for about 10 years, we were focused on one thing, so basically to provide localization for mobile robots using flow texture. And as you see, with that focus, we were able to get some success. So we have like over thousands of robots in operation using the Triton all across the globe. So the beginning of this year, something amazing happened. We got acquired by SICK. So now we are actually a part of a much bigger company where we have a much stronger global network to actually take a product to a lot more customers. But also the other advantage that we see is that we are now part of the SICK localization portfolio. So now we have varied technologies for the industry. So our customers can benefit from this range of technology that we have, and they can get an edge in terms of performance, and also we can solve a lot more challenges that we generally see in the space. So moving on to what sort of challenges or what sort of problems that we actually see with mobile robots generally. So what we see is that mobile robots in operation, they generally get limited by the localization system. And we have identified about 3 main pain points. The first one is driving in dynamic environments. This generally causes errors or stops. The second one is commissioning sometimes can be quite complex or costly or time consuming. And if you want to change the layout, there could be some downtime because current technology is not very flexible. And the third one that we keep hearing quite often is that the performance of the robot isn't good enough in terms of accuracy or speed. And this also could limit the throughput of an operation. And we believe a solution for this could be the Triton. So I just want to talk about what the Triton is. And since you guys probably may have heard of it, or if you're hearing it for the first time, this is probably a good introduction for what Triton actually is. So Triton is actually a camera-based localization system for mobile robots, and it uses the floor to localize. So it's a camera that faces down on the floor, as you see in the image over here. So you have a module, and what we have done is the secret sauce is in the software, and we have encapsulated all this into a nice hardware device. So we have the camera, the computation board, and also the illumination all packaged into a hardware device that we call as the Triton. And the Triton, it localizes by scanning the natural features on the floor and recognizing that to actually provide you the localization information. So in the previous presentation from Sebastian, you would have heard about contour-based localization, where you look at the contour of the environment. But in this case, we look at the natural features of the floor. And we have realized with this sort of application, it fits really well with interlogistics, especially for indoor logistics and also for manufacturing operations and so on.
So Irfan, basically, it's a camera that is taking pictures on the floor
Yes.
a lot of pictures, and creating a map of the floor of the on the track that the mobile robot should follow. So
Yes.
it's list this as a route, as a track to follow, and
Yeah.
the robot knows where it is because it's able to identify the surface on the floor that is a storage in the brain of the mobile robot.
Yeah. Indeed.
I'm saying in not engineering words, okay, but this is the concept is something like this.
Yes, it's actually you described it quite well, and I actually have a video that will come up quite soon that actually shows this in process. We'll talk about how the mapping is done and the localization is done, also how it's done for a couple of applications.
So the idea, I guess that the idea here was to avoid all the dynamic environment that we used to have, we typically have in the mobile robot business. When you you map your system, then you find that something changed, containers or walls or a new machine or something
exactly
that is completely independent from the not completely because you depend on the floor, but completely on the other environment. I mean, on the vertical world. It's independent from the vertical world. Let's say it this way.
Exactly. So, like you said, and that's also what I want to talk about. Like, just since we're looking at the floor, if I want to tie it to the issues that we saw earlier, and like you said, one is in the dynamic environments. You're not looking at any of the vertical walls, so they'll be independent of those contours. That way, we can localize quite reliably and accurately also. And next is we don't need any sort of infrastructure, so no stickers or reflectors. So your commissioning and your layout changes can be a lot more faster. And the third one is on another hidden feature is another feature which is basically your accuracy. So we can get up to about 1 mm of accuracy, which we think is really good for things like docking and also for high-speed driving.
Okay.
Yeah, and apart from this, of course, there's another host of benefits and features that we bring. One is if there are any changes in the floor, so there's scratches or scuff marks, Triton can actually pick up these changes and update it back automatically. And this way you can
like a dynamic mapping that we know for the sometimes in the line. Okay.
Yeah, and this way you can actually extend your life of your map and a more robust solution against changes on the floor.
Okay.
Yeah. And like our sister product, PicoScan, we also do the processing on board. So it's also a nice plug-and-play solution where you can use it as a standalone localization solution.
Okay.
And we can also easily integrate into existing vehicles because we have a nice API that can also integrate quite easily with the navigation stacks.
Okay, I think it's you say integrating into the. I know it's quite new. Okay, that you arrived to the SIG world. Okay, the Axerion arrived to the SIG world, but I guess I can imagine that the target is to integrate also the Triton solution into the navigation solution from SIG, from the LiDARloc. So in order to have also this option as a sensor, this is change also, we can change from the PicoScan LiDAR navigation to the Triton. I guess this is something that you are working on or not?
Yes, there's definitely something that we want to, that we're planning to do. Of course, it's just been a few months since we are part of SIG. And the main thing is to integrate our teams. But the next step is definitely integrating the products also. And it's not just because we are now part of the same family. We do see a lot of benefits in both the systems working together. Yeah. So I can also touch upon that a little later too. But yeah, like you said, having a combined solution is something we are aiming at.
No, I mean, from the user point of view, it makes a lot of sense. This is why I'm asking you, because it's the natural evolution of this. I mean, a conglomeration. How do I say? Working together. I mean, I would like if I have to buy this from you, I would like to have all these options. This is what I think.
Yes, certainly. Like I said, we want to give the options to the customer, but also have a combined solution that brings a lot of value to them.
Okay, good.
Yeah. So, Alfred, I'm sorry I have to keep you waiting, but I have a nice video that talks about how the Triton works. It's done by my colleague, and I can quickly
how Triton works. Hi, my name is Demi Kramers, and I'm an application engineer at SIG Axerion. Today, in this video, I will demonstrate how Triton works. Triton's core functionality is absolute localization based on the floor map. So before we can localize, we first need to create that map. For most applications where vehicles navigate freely, we map a sparse grid consisting of horizontal and vertical lines. In front of me there's a tabletop which represents the floor where the robots will drive on, and I already mapped a couple of lines. On the screen you can also see these lines visualized. I will now map the final line to complete the grid. As the Triton moves, it takes images of the floor, extracts a unique signature and stores that in its database. Each signature is tagged with a position and heading, provided by an external reference, such as LiDAR-based localization. Now that our map is done, we are ready to localize. As I move the Triton over the mapped area, we can see these green arrows appear. These represent absolute poses from the Triton based on floor recognition, accurate to the millimeter. When moving between the lines, the robot temporarily relies on wheel odometry, and if that's not available, you can use Triton's odometry instead. This enables reliable and accurate localization even in the most dynamic environments. For use cases that involve virtual line navigation or docking, you can choose to only map the required paths. This enables you to get maximum accuracy with minimal setup time. Thank you for watching.
Yeah. So like my colleague showed, he showed a demo with the Triton, where he showed the mapping and also how the localization is done. And just to sum it up, we first create a map by taking pictures of the floor. We store that in the database. And during operation, we look at what is on the floor. And if there's a match with the images in our database, then we know exactly where we are. My colleague also showed a couple of situations or ways of mapping. And I can quickly, like you said, you can either create a grid if you want to do a free navigation, or you can just create fixed paths to drive on a certain route. And so Triton is quite flexible in how you want to use it for your particular use case also.
It's very, very interesting, Irfan, because I think it's a natural evolution of some kind of magnetic tape navigation, okay? Yeah. Because honestly speaking, I find still in some cases, for the environment, for example, very aggressive automotive body in white or body shop that are very aggressive also for the LiDAR, for the robots, a lot of forklifts, a lot of things that moving. For the floor localization is very, very, very challenging. So that sometimes we need to, I think that it's still reliable, this type of, let's say, magnetic tape. What is the problem? That is you have a problem with the not the reliability because the navigation is working, but the magnetic tape used to get wear, it disappears, it's stuck, okay? But it works when it works, okay? So in this case, you are doing more or less the same thing, but following the floor, okay? So you are not linked, you do not depend on the environment, which sometimes is completely a mess. I mean, you can put
indeed.
A lot of slam, okay, but sometimes it's really impossible.
Yeah, indeed.
And no, it's the natural evolution of that. I mean, for me, it's a very, very interesting thing.
Indeed, like you said, there's some situations where just slam doesn't work, and then you really have to use Triton. And also, we see that if the environment becomes too dynamic, things like docking also becomes a big challenge, and you really have to use something like Triton to actually do that. Yeah. So I think we already just started talking about it, but the next is I want to talk about what are the different types of applications for Triton. And like I said, it's mainly focused on mobile robots for indoor localization for warehousing and manufacturing. And I want to talk about two of them. One is AGVs in manufacturing environments, and another one is for high-speed sortation. They're quite different. And like Alfredo, you said, one is based on just basic line following. And the other one is you'll see it as I speak.
Okay.
So so this application of AGVs in manufacturing. What we generally hear about, or rather how this really works out is, as you can see in the images we hear, you have a vehicle that drives in a manufacturing environment where the environment is quite dynamic. The common technology they use is like things like magnetic tape or induction wire. But we do hear a lot of pains related to this. One could be on the commissioning side. Or like you said, even just the reliability could be an issue. With Triton, what we can do is we can just record fixed paths where the vehicle wants to drive. So it can just be paths like you see in the image on the left. And this actually becomes very easy to implement. So you can just have a technician to do the mapping. And also, it's the setup is really quick. So you can do the whole warehouse or your manufacturing environment quite quickly. So one of our customers, Kumartech, they do it in in less than 2 days. And they do it with the technicians. The whole thing is also very cheap.
Mm-hmm.
And if you look at how it goes on during the operation, yeah, they can drive quite well in dynamic environments. You can have things moving around. Doesn't really affect them. And if they have to do things like docking, it can be done quite easily with the Triton.
Imagine, Irfan, that 2 or 3 years ago, I installed around 4 kilometers of magnetic tape in an automotive manufacturer here in the south of Italy.
Okay.
It was not even magnetic tape applied on the floor; it was embedded on the floor. So we have to cut, put the magnetic tape square one, then mix some resin. It took weeks and weeks and weeks, and then you have to modify. You have to modify a curve. You have again cut. Oh shit! It's another world.
Yeah, it's horror stories that we also hear, and so with the Triton, you can actually also modify your map quite easily. So you can remove parts of the map that you no longer need, and just map in another area. And this way, your whole solution is also very flexible.
I have to say that it took time. It was complex, but it is still working. It's 7 years there. Okay, so
yeah, indeed.
But if I had this solution at that time, of course I would prefer this one. That's
indeed.
Okay.
Yeah, certainly. Just to highlight how a customer does it, I can just show you how it works for them. Customer called Kumartech, they're based in the Netherlands, where they use AGVs or AMAs such as this in a manufacturing environment. And you can see that there's no sort of lines in the ground or any sort of markings. They sometimes have something for visual aid, but apart from that, nothing else. And they can drive quite well in even dynamic environments. And if you look at how they do some things like docking, especially with such large welding jigs, with the Triton, it becomes really, really reliable and easy.
Excuse me, Irfan, I don't know if you said what is the accuracy of your system?
So we say the repeat accuracy is about 1 millimeter.
1
especially
millimeter.
for things, for docking.
1 millimeter.
Yeah, indeed. That's a repeat accuracy. Yeah. Okay, I can go back to my presentation and talk about the next application. This is mainly for, let's say, high-speed sortation application. So it's quite different from what you saw earlier. But in this, like you can see in the image over here, it's basically bots that move parcels around or just goods around. And in such situations, what we see is they generally use QR codes or tags on the ground, and they're limited to basically driving from one tag to another. And that becomes quite painful in terms of commissioning, because you need to spend a lot of time sticking these codes on the ground. But also in operation, you are now just limited to just driving on fixed or rather from one code to another. And you really can't optimize your paths. So with Triton, what we can actually do is first we can automate the whole commissioning. We can map a grid of your environment, and you can do this with a robot. In fact, I'll actually show you a video on this after this. And we can actually do it so fast that we can do about 1,000 meters square in less than an hour. Yeah. And if I look at how it would be in operation, first is we can drive at a higher speed, or rather we can drive quite accurately at a higher speed. And this way your whole operation can be quite dense. But also we can optimize our paths. So we don't have to drive on tags. You can actually drive more dynamically. And this way the throughput of your operation also goes up. And so this is something that we have also done quite successfully. We've seen a lot of success with this, and something that we see is a very good fit for such use cases also. Yeah, so I can talk about how we do the mapping in such situations. We can actually map quite fast, and I can talk you through the video of this. So the first step in mapping such an environment is we start by exploring the environment. So we do this by building a SLAM map. And now that we know where this area is, we can choose the area where we want to map with the Triton. And then we can plan the path where the Triton needs to drive, and we can then create a grid. So you can see that the video is sped up, but I can also tell you that the person who did this mapping, he actually wasn't there when the whole operation was taking place. Yeah, he had just gone for a coffee break. Once he was back, he had actually mapped the entire environment, and yeah, he was ready for operation then.
You can use the LiDARloc to map the to.
Yeah, certainly. That's what we want to push for.
One question. Yeah. Fun. Is there because there were some questions in the chat?
Yeah.
Several people asked it. What are the technical specifications required for the floor? Do you have some kind of technical specifications, or
yes,
or not?
That's a good question. Like for us, concrete floors work really well. Yeah, so it's usually a green flag when we have concrete floors. We also have a let's say a list of floors that we have whitelisted. It's a catalog that we can always offer to anyone who's interested. Yeah, and if there's any new floor that we see for the first time, or the customer wants to use a floor that they have existingly, then what we can do is we can also send a Triton, and they can create. Yeah, they can just map the environment or map the floor, and we can analyze it. So that way we can see if that floor is compatible with Triton. Yeah.
Okay.
In general, if you have a floor that has patterns, then it would work. Or if you have a concrete floor, you can be sure that Triton would work for you.
Okay.
Yeah. So I have a couple of minutes, and I would be happy to brag about some things that we have done, especially with the team. First is we can map like large areas up to 20,000 meters square. Also, multi-level operations is something that we can do. And for one of our customers, we have a map that's now, I think I've updated this, but it's been operational for more than 5 years without actually remapping. Then with Kumatech, like I said, we can, with their application, they can do the whole deployment in less than 2 days. And you can also get like millimeter level of accuracy for docking. And with the customer called Prime Vision, we deployed over 700 robots in about 40 sites in like less than 6 weeks. And this was all possible because of the way they do the mapping. It's all automated, and it's a lot more faster than the traditional ways of doing it. And finally, want to conclude, I think, on behalf of myself and also Sebastian. So so you saw that two different types of localization technologies from SICK. The aim is to offer a wide range to our customers to choose from. So you saw the class-leading contour-based localization, so LiDARloc and PicoScan 150 loc. You also saw the Triton from our side. And within SICK, our main aim is to be a reliable technology partner. And I think what speaks for that is that the technology is industry proven, and we have like thousands of vehicles running in operation with our localization technology. Okay. And if I have to talk about the outlook, like what Alfredo had mentioned in the beginning, our aim is to also offer a combined solution. So something that you guys can look forward to. But it's not because we are just a part of one family. It's because we do see a host of benefits that it brings when we combine like contour-based localization with flow texture-based localization. And one is that you can drive in diverse environments, but also that we can improve the reliability of the robustness of our system.
Okay.
So thanks, guys.
Well, wonderful. I mean, we are 1 hour. Perfect, guys. 1 hour, perfect. Just because we still have quite a lot of questions, to be honest. So if you don't mind, I will just steal you a few minutes more. So people that are there, I mean, if you can leave, you can stay, because there are a lot of questions. In any case, of course, we cannot answer everything today, but I will send you all these questions, and you can contact the people, okay, directly, Sebastian and Irfan, because there are really interesting and very specific questions that are very, very nice. So, but let's try to answer at least a couple of questions more for each system, so for the LiDAR and for the Triton, okay, if you agree with me. Okay, so I start, for example, Giuseppe is asking 2 questions, okay, regarding the LiDAR, okay? So if multiple LiDARs are used, okay, how much effort is required for calibration? So identifying the LiDAR position on the vehicle.
Yeah, that's a good question. So the idea is to really mount the LiDARs accurately, and then you really need to know the position of each LiDAR, and then we have the mounting position in our configuration, and you enter the mounting position in the configuration. But we also have the possibility to color the different LiDAR scans differently, so you can see on a dashboard immediately if it is purely aligned, and then you can tune the mounting position until they perfectly match on top of each other, and this is how we can calibrate the LiDAR position.
And about the accuracies, okay, accuracies of the systems. The question here is if it is still valid in case of a fleet of vehicles. So if all the accuracies, all the errors are the same for all of them. I think it depends a lot on the hardware also, but
so in theory, yes. So if we manage to accurately calibrate the LiDARs and also the code reader. So for example, for the 1 millimeter, you need a code reader, and you also need to really precisely add the mounting position of the code reader. And if you do it, then you can achieve it for a whole fleet, of course. Yeah.
Okay. I have another question here from Danjan in Croatia. Hello, Danjan. What about the map updates? Okay, you have our map. How do you handle the map modifications? Is it possible to do manually, or is it also that can be done automatically, so dynamically while the robots are moving?
So our idea is to have a quite static map. So we recommend our customers to clean the map and remove all dynamic contours from the map. And by that, we are really able to deliver a robust localization. But of course, if there are major changes, you need to update the map. And in such a case, we have the possibility to update the map manually. So we have our desktop tool, and you can either update the contours or extend the contours. So if you add a new area, you can extend the contours. So this is possible. We don't have an automatic map update yet. So this is something what we are developing at, and this will come in the future. But currently, it is a manual process. But yeah, as mentioned, through the fusion of different sensor data and different options, also the option to add reflectors, we are very robust also in dynamic environment.
Okay, and this is another question that is also for several people. How does the PicoScan product range fit together with the nav? Okay, because we all know the nav 350. What are is a substitution, or there are different applications? How do you put all of this in your product range?
So a nav 350 is a pure reflector-based localization system or solution.
It's only for reflectors, okay.
You need to really measure accurately each position of each reflector, and this brings a very accurate result, but it's also a lot of effort for commissioning, and we believe that contour-based solution is the future. So this is what we do with LiDARloc, and also the nav 350 is quite huge and quite expensive. So with the PicoScan, we have a more cost-effective solution. But of course, the nav 350 come with an incredible range of 250 meters. So this is also a huge advantage. I think the PicoScan can cover probably most of the applications the nav 350 solve today. But for the really huge long-range applications, we have the LRS 4000, which is also a 2D LiDAR of SICK, which covers a similar range, and it can be combined with LiDARloc. But of course, you still can buy the nav 350. But yeah, it's quite huge device.
Okay. Another question that is also from several people. Arno here is asking, but there are other 3 or 4 people asking also this. What about the navigation? We said the localization, but explain us what is the current status of your navigation system?
So the current status is that we offer a lightweight navigation solution, which is especially interesting for manufacturers of mobile robots that already have experience with magnetic line followers. So the virtual line navigation, as the name itself says, so you can draw a virtual line in the reference map, and we output the deviation of this line, and you can use it and feed it into your line following controller and keep the robot on the line. So this is a lightweight navigation solution what we offer today, but of course we also look into advanced navigation functionality. So this is something what we are developing at, but there's no product launch yet. So for some interested customers might have the ability to do some beta tests if they want to. Yeah, this is something you can be curious for the future.
Okay, if you agree, Irfan, now I go to some questions about Triton. Okay, Sebastian, there are other questions. Okay, that honestly, let's go for the. Are you ready, Irfan? Here we have Brad is asking, how difficult is to initialize the vehicle using Triton? In the meaning that how do you know the initial position in the map? Okay, because the camera is relatively small. Okay,
indeed.
So how do you do this?
Yeah, it's a good question. We do have a feature called the buffered recovery mode, where we can actually use to do this initialization, or in case of the kidnap robot problem, to actually recover our location. And as long as you're in a mapped region, so not somewhere else, but the region that you're mapped, and you drive over a couple of signatures from that you're mapped earlier, you'll be easily able to initialize or find your position that you lost.
Okay. Other question. Well, we already spoke about the floor floor requirements, but how is the Triton switchable? There's a couple of questions regarding for example, for freeze environments, for cold storage. Is it suitable or not?
So we haven't done a test in those environments, but usually we drive, let's say, in ambient temperatures, or I think the lowest one that we have gone down to is about 4 degrees centigrade, more in a food processing environment.
Okay. Another question that, again, a couple of people here asked is is it easy, or is it possible to convert a magnetic tape robot to the Triton-based navigation robot?
Yeah. So like we had given an example of one of our customers, Kumatek. Yeah, it's actually quite easy to just localize, or rather navigate with just this virtual line, the Triton, and you can either do it by mapping using a laser scanner in the beginning, or you can just use Triton to do it, and it's quite easy that way. So with this fixed parts, like I said, the commissioning is actually very easy there.
And excuse me, let's come back to the floor condition, because I guess it's important. You are relying on the floor. So also we have Alistair. Alistair is asking, what about the dust? Because there are some environments you have dust on the floor. Is it a problem? How do you handle this? Or maybe you tell me, no, do you have dust? Is not suitable, or yes, we can handle. Okay, how does it work?
So that's also a good question. So we do see a lot of operations where there is dust, and we haven't gotten too much feedback on this. But we do recommend like a cleaning procedure to keep the Triton maintained. And even if you do it during a maintenance of your vehicle, that's good enough. But I don't see it as a big risk. Of course, like if you have like mud everywhere that changes the flow completely, then it's something that I would be worried about, indeed.
Okay. Yeah. Okay, well, I mean, there are still quite a lot of questions, but we are going far. I guess you guys have something better to do than being here with me today. So afterwards, so thank you a lot for your time. For me, everything is fine. I will say to the audience, thank you very much. Again, a lot of people, very interesting questions this time, honestly. And we will send a presentation, okay, this presentation for you. maybe tomorrow is already possible. All the questions, okay, that have not been answered today. In any case, we can contact you by email. Sebastian or Irfan can answer to these questions. So thank you very much for your participation, for your engagement, because honestly, a lot of questions that is helping us to create a more interesting webinar for everybody. Okay, Sebastian, thank you very much. Great explanation. For me now it's clear everything. Irfan, again, thank you very much. Thank you for your time.
Thanks, Alfredo. Thanks for hosting.
We stay in touch, and bye-bye.
Thank you, everyone. Bye-bye.
Bye, everyone.